Hello, my friends. I'm Clover, and this is Genuinely Approachable Sudoku, and today we are solving Two Deadly Givens by Philip Newman. This is an XV Sudoku, not XV pairs, so that means there is a negative constraint here. In the case of this puzzle, because there are no X's or V's marked in the grid, that means that any pair of digits that are orthogonally adjacent, like these, or these, or these, and so on, cannot ever sum to 5 or 10. So for instance, I can't put a 4 in either of these cells because 4 plus 6 is 10, and so 4 can't ever go next to 6. We also have standard Sudoku rules, meaning we're placing the digits 1 through 9 once each in each row, column, and outlined 3x3 region. So let's start in the middle. We need 1, 2, 3, 4, and 5 to finish this region. This cell can't be 2 or 5 because those are in the row. It also can't be 3 because it is touching a 7, and 7 plus 3 is 10. This can't be a 2 or a 3 because those are in the column. This can't be a 1 or a 4 because those are in this column. This can't be a 4 or a 5 because those are in this row. It also cannot be a 1 or a 2 because 1 plus 9 is 10 and 2 plus 8 is 10. So that's going to be a 3. Now 3 can't go next to 2 because those sum to 5, so that has to be our 2. And from there, this can't be a 5 because there's a 1 there. That's going to be a 5, and that's going to be a 4. Okay, now we're going to look at the central columns and rows. These will be 2, 4, 7, and 9, and I can't have a 2 here or a 4 here. Also, 2 can't touch 8, and 4 can't touch 6. So that gives me a 7-9 pair. That'll place a 4 here and a 2 here. In this column, I have 3, 5, 7, and 8 to finish off, and I can't place 3 or 8 there because those are in the region already, so that's going to be a 9 and a 7. And those are going to be 3 and 8. And here, I need to finish this column. To finish this region, I need 1 and 6, which will go like that, because the 1 can't touch the 9. And these are going to be 5 and 9. Now, if we look at the central rows, these are going to be 1, 3, 6, and 8. That can't be a 1 because it touches a 9. That can't be a 3 because it touches a 7. These cells are going to contain 3, 4, 8, and 9, and because there's a 4 and 9 in this region, that becomes a 3, 8 pair, making that a 6 and making that a 1. That's now an 8 and a 3. And these two digits are now going to be 1 and 6 to finish off the region, and these are going to be 2 and 7. Okay. 7 can't touch a 3, so that's going to be an 8, and that's going to be a 3 right there. Now, 1s are there and there, and 1 also can't go there because there's a 1 in this row. And 1 can't touch 4, so 1's going to have to go right there, and then 1 is also going to go in one of those cells. 3s are here and here. 3 can't touch 2, and there's already a 3 in this row, so that's the only position for 3 in column 7. So now in the rest of this column, I need 1, 4, 6, 8, and 9. This can't be 4 or 8. This can't be 1, 6, or 9, or 4 because it touches a 6. That's going to be an 8. This can't be a 1 because it sees a 1 there, or a 9, or a 4 because 9 and 4 can't touch 1. So that will be a 6. And I'm just continuing to kind of simplify. And I think that that is all I can do with that right now. This can't be a 1 because there's a 1 right there. And this can't be a 1 or a 4 because those appear in the row already. So that's a 9, and we can actually finish this off. So that's a 5, and that is now a 9. Now if we look at this column, we need 2, 3, 6, 7, and 8. That can't be 7 or 8 because those appear in the row. It also can't be 3, and it can't be 2 because it touches a 6. So that makes this a 6. This can't be a 3 because it sees a 3, or a 7 because it touches a 3. That can't be a 2 because it sees a 2 in its row. This can't be a 3 or an 8. And this can't be a 2 or a 3. So this is now the only position for 3 here. And 3 also can't touch 2. So that has to be an 8, 7, 2, 5, and 7 right there. Now let's look at these rows. These are going to contain 2, 6, and 7. That can't be a 6. And these cells are going to contain 4, 8, and 9. That can't be an 8. Now, there's only one position remaining for 4 in this region, because there's a 4 there, which sees these cells, and 4 also can't touch 1 and 6. The 4 has to go right there, and this is not going to be a 4. So the remaining digits in this region are going to be 2, 5, 7, and 9. That can't be 7 or 9 because it sees those, and those can't be 2. That also can't be a 7 because it touches that 3 right there. These are going to be 1, 2, and 5 to finish off the row. 2 can't touch 3. And these are going to be 5, 7, 8, 9. This can't be an 8 because there's an 8 in the column, so this is going to be an 8. That eliminates a 2 because the 2 can't touch 8, so that becomes a 2. And that lets us do a bit of Sudoku. Now in this row, I need 5, 6, 7, and 9. Can't have a 7 there because there's a 7 in the region. That can't be a 6 because it sees a 6 in its column. And those can't be 6s because there's a 6 in the region. So this is going to be a 6 right here. We also have a 5, 9 pair here, which eliminates a 9 from that cell. We have a 2 there, which gives us a 7. And so here I need 3, 4, and 8 to finish off the column in those 3 cells. And that can't be an 8 because it sees an 8, and it can't be a 4 because it touches a 1. And that can't be 8 or 9, so this must be my 5. That's a naked 5. Those can't be 9 because there's a 9 in the row now. And the 7 there gives us a 5 and a 7. And we're just finishing off with some classic Sudoku. And that is how you solve Philip Newman's Two Deadly Givens. I hope you guys liked that one. The link to solve it is in the description of this video, and I will see you again in a few days.